today we are going to deal with binary arithmetic, in which we are going to see the following topics. The topics are 1's complement subtraction, 2's complement subtraction, 9's complement subtraction, 10's complement subtraction and BCD codes. Now first let us see what is 1's complement subtraction. In 1's complement subtraction, we have to follow certain rules. The steps involved in 1's complement subtraction are: first we have to take the minuend as it is, and the subtrahend, whatever is given, should be converted to its 1's complement. So that's why you can see here, take the 1's complement of subtrahend and add it to the minuend. If a carry is produced, add the carry to the sum, and if a carry is not produced, then what it indicates is that the result is negative and it is in the 1's complement form. So let us take an example now. The example that I am going to take is, let us find the subtraction of 10101 and 1000 using 1's complement method. Now we know that the binary number 10101 is equivalent to 21 in the decimal number system, and the number 1000 is equivalent to 8 in the decimal number system. When we subtract 8 from 21, the result obtained must be 13. Now let us see how we can get the same result by subtracting the two binary numbers. So before we proceed, let us look at the rules and the steps that should be followed in 1's complement method. The first rule is we have to take the complement of the subtrahend. The second rule is we have to add the complement of the subtrahend with the minuend. And the third rule is, if a carry comes in the result, then that carry should be added with the rest of the numbers in the result to get the answer. And the fourth rule is, if there is no carry, then the 1's complement of the sum will be the result and it will be negative. Now let us take the example that we have and see how we can do the subtraction by 1's complement method. The numbers are 10101, which we will take as A, the minuend. The second number is 1000, which we will take as the subtrahend. Now to do the subtraction by 1's complement method, we have to take the complement of the subtrahend. And how do we get the complement? We subtract the number, that is 1000, from 11111 to get the complement, which you can see we have done. I've shown the method below, which shows 11111 minus 01000, and the complement comes as 10111. So this complement must be added with the minuend, which is 10101, which is shown below. And when we add, you can see the leftmost bit is the carry, which is a 1. That 1 is added with the remaining numbers, as you can see below, and we are getting the result as 01101, which is nothing but 13 in the decimal number system. So this is how we subtract the two binary numbers using 1's complement method. Let us take one more example, and in this example what I am going to take is, I am going to take a very small number, 7 minus 5. Usually when I subtract these two, I should get 2. Now let me write the binary equivalent of this 0, 1, 1, 1, and the binary equivalent of this 5 is 0, 1, 0, 1. So when I subtract this, I should get the answer as 2. So this as usual is the minuend and this is the subtrahend. Okay, so when we follow the rules of 1's complement, what we have to do is the minuend should be taken as it is. So minuend is 0, 1, 1, 1, and 1's complement of subtrahend. So 1's complement of 0, 1, 0, 1 will be 0, 1, 0, 1. So you can see when I add up, I get 0, 1, I get a 0 and 1. This 1 is a carry. So according to the rule, this 1 should be added with the sum and the answer becomes 1, 0. And 1, 0 is nothing but, the decimal equivalent of 1, 0 is nothing but 2. So this example clearly shows you that how subtraction can be done by using 1's complement method. Now we have seen only one part of the rule. In the rule it also says if there is no carry, the answer should be taken as negative and the correct answer will be the 1's complement of whatever we get as a result. Let us see also that as an example now.
Where I am going to subtract the binary number 10001 from the binary number 1001. The decimal equivalent of the number 10001 is 17 and the decimal equivalent of the number 1001 is 9. Normally, when we subtract these two numbers, we get the answer minus 8. Now let us subtract the two binary numbers using 1's complement method and see whether we can get the same result. So let us take the number 1001 as the minuend and 10001 as the subtrahend. Then, according to the rules of binary subtraction by 1's complement method, let us take the complement of the subtrahend and the complement of the subtrahend will be 0, 1, 1, 1, 0. And let us add this with the minuend. And you can see when we add, we get the result as 10111. And here you can notice that there is no carry. And if there is no carry, the answer will be the complement of this number. The complement of the result will be 0, 1, 0, 0, 0. And the answer will be minus 0, 1, 0, 0, 0 as per the rules, which is in decimal number system equal to minus 8.
Now let us take one more example to understand this better. We will take 8 minus 9. I am getting minus 1. It is 1001 and 1, this should be 0, 0 here and not 1, and here it is 1001. So when I take this number, I can take this as it is without any change, whereas I should take the 1's complement of this number. Now when I add up, I am getting 1, 1 and 1. So we find that there is no carry here, which means this result is negative and also the 1's complement of this number. What will be the 1's complement of this number? It will be 1 0 0 with a negative sign, which is actually 1. So this is how 1's complement subtractions are carried out. Now let us go on to the next topic, which deals with 2's complement subtraction. What is meant by 2's complement subtraction and how 2's complement subtraction can be done? In 2's complement also we have to follow certain steps. Now what are the steps involved in 2's complement? Let us see. It will be almost same as the steps that is followed in 1's complement, except for certain small alterations in the last step where a carry comes. Here again we have to take the minuend as it is. There should be no change. We should not change the minuend at all. But when it comes to the subtrahend, we have to take the 2's complement of the subtrahend and we have to add it to the minuend. If a carry is produced, see, this is the difference. Earlier what we did was, when a carry was produced, we added it to the sum. But here you find that if a carry is produced, that carry should be ignored. And if a carry is not produced, then it indicates that the result is negative and it is in the 2's complement form. So let us again take a simple example, 8 minus 5, which gives me 3. What is the binary equivalent of 8? It is 1 0 0 and binary equivalent of 5 is 1 0 1. So here it is said that we have to take the minuend as it is. Which is the minuend here? The minuend is 1 0 0 0, whereas I have to take the 2's complement of, this number 0 1 0 1. What is 2's complement? It is actually, we get 0 1 0, we get a 0 here and a 1 here, but we have to add one more to this, which will make it. So you see here I will get 1 0 0 0, which is the minuend, but 2's complement, this particular thing will become 1 0 1 1. So this is the 2's complement of this number that I have taken. Now when I subtract this, when I add this, I will get 1 1 0 0 and a 1, which is a carry here. And the rule says, if I get a carry, what should I do? I should ignore it. And if I ignore this carry, the answer is only 1 1. And 0 0 1 1 is nothing but 3. So this is how 2's complement subtraction is done. And again we saw there is another part for this rule, which says that if there is no carry, then we should take the result as negative and the real answer will be the 2's complement of whatever we get. Now let us see that example also. It means, okay, I will take this number here, I will take 9 minus 10. 9 minus 10 should give me minus 1. Okay, 9 is 1 0 0 1 and this is 1 0 1 0. So if I take the 1's complement of the second number, what I should get is, actually I should get 1 0 1 0. If I add a 1 to this, I should get 0 1 1 0. So this is the number I should add here. And when I add this, this is the 2's complement. Okay, this is the 2's complement of the number that I have taken as the subtrahend. Now when I add this, I get 1 1 1 and 1. See, there is no carry. There is no carry, which means this answer is the negative result and I should take the 2's complement of this. If I take the 2's complement, you can see I will get, first I have to take the 1's complement of the 4 numbers, binary number, and I have to add a 1 to it. So what I am getting is 0 0 0 1 and the rule says this answer is negative. So that is what exactly we are getting here also, and this is how we do binary subtraction by 2's complement method. So if we have a carry and if we happen to get a carry or a carry is produced, then that carry should be ignored. If there is no carry, that means the answer is negative and we have to take the 2's complement of it to get the actual answer. So now having seen this, we will go to the next one, which is nothing but 9's complement subtraction. Now 9's complement subtraction also involves 3 steps. It also says that the minuend should be taken as it is. So, in all the complement method we find that the minuend should not be changed, it should be taken as it is. And then when we come to the subtrahend, we have to take the 9's complement of the subtrahend and add it to the minuend. If a carry is produced, then that carry should be added to the sum as we had done under 1's complement method. And if a carry is not produced, it indicates that the result is negative and it is in the 9's complement form. So, let us take an example now. The example what we are going to take is, we will take a simple example like 9 minus 5. So, you can see here the 9 can be taken as it is, that is a minuend, but when it comes to the 5, I have to take the 9's complement. 9's complement of 5 will be, how we take the 9's complement of 5 is, we have to take 9 minus 5, which will be 4. So, I have to take the minuend as it is. The 9's complement of 5 is 9 minus 5, 4. Now, I have to add up this 3. When I add up the 3, I will get, not 3, I will get 5 here, I will get 5. When I add up, I will get 3 and a 1, okay, I will get 1 and 3. And we have taken the 9's complement of 5, which is a subtrahend. And when we take the 9's complement, we get 4, which is nothing but 9 minus 5. And that 4 is added with 9 to get 13. And here this 1 is a carry. And according to the rule, this 1 should be added with 3 to get the right answer, which is again 4. Now, we are going to see another part of the example where we are going to get a negative answer. So, let us take an example like 17 minus 9 or 17 minus 20. The answer will be minus 3 here. Now, 17 minus 20 means this is a minuend, this is ordinary subtraction. Now, I am going to do the same thing using 9's complement method. So, I have taken the 17 as it is. How do I take the 9's complement of 20? It can be taken as 9 minus 20, which is nothing but minus 11. So, I am going to write minus 11 here and then add the 2. Okay, I am going to add the 2 numbers. When I add, what will I get? I will get 6 as the result. But this is not the correct result, as I told you. This is, we have to take the 9's complement of 6 to get the right result. So, how to take the 9's complement of 6? It is 9 minus 6, which is nothing but 3. So, the answer is actually 3, but we have to put a negative sign as per the rule. So, the rule says that if we have a number like this without a carry, then what we will have to do is, we have to take the 9's complement of that number to get the right answer, and that answer will not be positive, but it will be negative. Now, this way 9's complement subtraction can be carried out. Now, we will see one more complement method of subtraction, that is nothing but the 10's complement subtraction. So, let us take up that next to understand what is the meaning of 10's complement subtraction. Okay. Now, in 10's complement subtraction also, we follow almost the same rules, but see, now here again I have given you the examples of normal subtraction and 9's complement subtraction of the same number to make you understand it better. So, you can see that 1 is taken down and added up with that to get 3. Okay. So, now we will go to the next one, that is 10's complement, where we take the minuend as it is, and now we have to take the 10's complement of the subtrahend and add it with the minuend. If we get a carry, that carry should be ignored here. Like in 2's complement method, here again the carry should be ignored, and if there is no carry, then again the answer will be negative and it will be in the 10's complement form. So, let us take up an example now to understand this better. Again, I have taken the same simple example where I am subtracting 5 from 8. You see that we get 3. This is normal subtraction. Any subtraction will give us this result. Now, in 10's complement, what do? We take the minuend as it is and we take the 10's complement of 5. How do we take the 10's complement of 5? We subtract that 5 from 9 to get 4, we add up 1 to it to get 5. This is how we take the tens complement of a number. And then what we have to do is, we have to add it up. We get 13. And as per the rule, we have to ignore the carry. So once we ignore the carry, the answer will be just 3. So this is how tens complement subtraction is carried out. Now, having seen all this, there is another part of the binary numbers that is very important when it comes to handling computer or any arithmetic dealing with with computers. Now, BCD number is also a very, very important number system. It's called the binary coded decimal number or binary coded decimal codes. The necessity of this is only this. See, all digital circuits offer only 2 states, namely high and low and on and off, or 0 and 1. In the previous lecture, we have gone through binary number system and binary arithmetic. In binary number system, the number of bits required goes on increasing as the number becomes larger and larger. Also, some special binary codes are required to represent alphabets and special characters. Digital calculators, multimeters, etc. prefer 4-bit code to represent binary numbers 0 to 9. For this purpose, binary codes have been developed. Now, we will first look into what is the meaning of BCD code, especially 8421 code. Now, this is a group, any group of bits, especially 4, which are used to represent decimal numbers 0 to 9 are called binary coded decimal codes or BCD number or BCD codes. Most popular BCD codes is the 8421 code. 8421 represents binary weights 2 to the power 3, which is 8, 2 to the power 2, which is 4, 2 to the power 1, which is 2, and 2 to the power 0, which is 1. So that is what 8421 means. Using the 4 bits with weights 8421, we can easily represent the decimal numbers 0 to 9. To understand this, you can look at this table. In the table, I have shown how a decimal number can be written in the 8421 BCD code, or number, whatever we call it. We can see the 0 as 0000, and see it all represents 0 means 1 into 0, 2 into 0, 4 into 0, 8 into 0. That will give you 0 only. If you take the decimal number 1, see it is only 1 into 1. So you get a 1 here only. All the other numbers are 0. If you take 2, according to the weights, this is only 2. All the other numbers are 0. So you get 0, 0, 1, 0, which represents a 2. The 3 is written as 2 plus 1, 3. So 0, 0, 1, 1. 4, you can see is written as 0, 1, 0, 0. Same way 5, you can see 4 and 1 alone is 1, 1. The other two numbers are 0. 6 is 1, 1, 0. It is 4 plus 2, which becomes 6. 7 is written as 0, 1, 1, 1. So these are called, 8 is again written in this form, which you can see 1 is written only corresponding to 8, and 9 you get when you add up 8 and 1. So this is how the binary numbers are written. But you will observe from this table that some numbers are missing. Actually, there should be 16 numbers here, but 6 codes are missing. What are those codes? Let us see. From the table, it can be observed that the 6 combinations 1010, 1011, 1100, 1101, 1110 and 1111 are invalid BCD codes. So whenever we come across these numbers, we cannot take them as BCD codes at all. Any decimal number greater than 9 can be represented in 8421 BCD by repeatedly using 4-bit code for each digit. For that, I have shown an example here. A decimal number 29 can be written as, you can see here, 0010, and for 9 I can write 1001. Same way 97.5, see for 9 I get 1001, which is 8 plus 1, 9. For 7, I have written 0, 1, 1, 1, which is 4 plus 2 plus 1, 7. And for 5, it is 0, 1, 0, 1, which is 4 plus 1, 5. So, this way we can represent a BCD number. Now, let us see how BCD addition can be performed. Now, when we perform BCD addition, we follow the same rules as that followed for binary addition. The addition rules and all are same. 0 plus 0 will give 0, 0 plus 1 will give 1, 1 plus 1 will give 0, 1 plus 0 will give 1, but 1 plus 1 will give a 0 with a carry 1. So, that is how binary additions are carried out. The same way BCD addition can also be carried out. Let's summarize what we have seen in today's lecture. In today's lecture, we learned about how subtraction can be done by 1s, 2s, 9s and 10s complement methods. Also, in this lecture, we had discussed the importance of BCD codes. And after the discussion, we saw just one code, BCD code, mainly 8421 code, which is widely used. And we also saw how binary numbers could be written in the BCD code, that is 8421 code. And after seeing all this, I feel that it's also important that you should also try some small examples to learn this particular method of subtraction in a better way. So, I'll just give you some questions which you try to answer. The questions are: subtract using 1's complement, and I've given two numbers here, 1100 minus 1001. The second problem in that 1's complement method is 1000 is to be subtracted. You have to subtract 1010 from 1000, and also given a problem where you'll have to subtract the same two numbers 1100 and 1001 from 1100, same way 1010 from 1000 using 2's complement. Since we have learnt about 9's complement subtraction and also 10's complement subtraction, I have given you two problems to be solved by those methods. So, here you can see that I have given a problem where you will have to subtract 4 from 10 using 9's complement method, and in the second problem you will have to subtract 23 from 12. Same way, using 10's complement also, you try to subtract 4 from 9 and 23 from 12. If you do these problems, it will give you fairly good idea about how subtraction of numbers can be carried out using the complement methods. Thank you.